re-architecting the internet with a cyber layer. We have no control over the internet, and we cannot change the internet infrastructure, such as physical routers, computers, switches, or the fiber optic cable's backbone. That make it. Fortunately, we can program the internet by creating a virtual internet or intelligent cyber layer on top of the existing internet. This cyber layer will be invisible on the public internet. It will just be like a new dimension. Like if we have, for example, 3 dimensions, we cannot see the 4th dimension. So this layer will be created as a next new dimension. So it will be invisible over the public internet. And the goal of re-architecting the internet with this cyber layer is to intelligently and securely connect people anywhere, remote workers, fixed or mobile. They can be in the offices, and then connecting things like Internet of Things devices, as well as mission critical operational technology or OT infrastructure, as well as processes, for example, running in the factories, industrial control systems, or the workloads running in the public clouds. As you can see, the goal is not only connect to people and computers like the existing internet is doing. This cyber layer that we are creating is also built as an internet for things. And we will see when we create this new dimension or cyber layer, it can carry the TCP/IP protocols, but it can carry any protocol like the IoT and OT devices uses a different set of protocols and data structures that this virtual cyber layer will be able to create. And we create this cybersecurity mesh by taking a distributed architectural approach. So you're going to see how this is different compared to the current internet. And this distributed architectural approach allows us for the security and network perimeter to be defined around the identity of a person, thing, or an asset. Like it can be person, thing, or any asset. This way, it enables a more modular, responsive approach by centralizing policy orchestration and distributing the policy enforcement. So you'll see in the cyber control, there's a centralization of policy control and orchestration, while in the cyber nodes, we implement the policy. So let's now get into the 3 components or the modules that build the foundation for the Cybermesh. So we start with the cyber control. As we said, there is no centralized control in the current public internet, and we are going to create this in the virtual layer. We are going to create this cyber control. So this cyber control is going to serve as the brains of the mesh. So this is what is going to centralize policy orchestration, and this is from where you are going to distribute policies for enforcement in the cyber nodes. So you can see the next module cyber node. You can call them secure virtual routers or inspection and enforcement engines. In other words, they are cybersecurity and digital experience engines with intelligence built in. Cyber nodes are aware of the identity of a person, thing, or an asset connecting through it. So as we said, it's very important to create this perimeter, which is identity and context aware. In contrast, the conventional routers in the internet are just dumb traffic forwarders. They may know the IP address, but they don't know the identity of the person or thing or asset on that machine or computer with that IP address. So this is why we use the word intelligent cybersecurity mesh. This layer has intelligence built into it. It is the identity aware. So because now you are going to do the digital experience management as well as the cybersecurity controls, so you can enforce those controls based on the identity, like not just based on the IP address, which has not much meaning here, other than it provides the information where to forward the packets. So this Cybermesh, as you see, eliminates the need for backhaul of data to a central location. Right? So you see, data is not going to before in the current enterprise security and networking data center is the hub. Everything has to go through it. But here is not the hub. Like if there are certain private apps over here and the user like to address those apps, they can securely go through it, still apps. But if the user is going to use the SaaS or internet, user is going to go like this. The user is not going to go through taking a detour through the data center. Right? So this way, rather than forcing traffic back to the data center for inspection, Cybermesh places these cyber nodes at nearby points of presence. Right? So endpoints can be users or IoT devices, factories, offices. They connect to local cyber node. Cyber nodes, you can call them points of presence. They connect there based on identity and context. All the traffic is inspected and forwarded as appropriate through the internet. The underlying network is still the internet, but you're creating this secure intelligence layer on top of that. So the Cybermesh design securely and intelligently connect users. They may be fixed at their home, remote users, or mobile users, the headquarters, branch offices, IoT and OT infrastructure, factories, with resources in either traditional data centers or more and more in the public cloud. So as more mission critical applications migrate to the cloud, the need to address security and digital experience, we call it cyber experience, will only increase. This need for highly secure, low latency access to digital assets, regardless of location, requires a tight integration of networking and security capabilities. So the cyber nodes integrate these capabilities. So Cybermesh can deliver in this promise by integrating cloud-based security services, full stack of cyber security now built into these cyber nodes in the cloud. So it's cloud-based security services and combined with the global fabric of cyber nodes or points of presence. And the third component of the cyber mesh is really trust paths. Right? You see, everything is connected. So these are the trust paths. Everything connects to the cyber node through these trust paths. So trust paths are secure virtual pathways set up using zero trust architecture. Like since you want to make sure the identity and context you are working on, based on you are working on, is a legitimate identity. Like so, before you even can identify a user, you have this zero trust exchange. Like before you create a trust path and then you allow the data to flow that trust path. So the trust path, they make any communications and transactions also invisible on the public internet. Right? So there's a multiple layers of encryption and quality of service controls, because you want to control the quality of service, digital experience, all the way to the users and to the device requirements. And with this strong encryption, you also make these trust paths invisible on the public internet. So this is what trust paths make everything invisible on the public net. You see, everything is going over these trust paths, and the only thing where you do inspection and enforcement are the cyber nodes. So trust paths, in a way, make this cyber layer invisible. So as in the security world, we say, if you cannot see it, you cannot attack it. So this is how this cyber layer creates a new dimension which is invisible over the public internet. Cybermesh also delivers multi-cloud networking. Like so for example, if you have some workloads, for example, here in Google Cloud, or applications, and some others in AWS or in Azure. Similarly, through the cyber layers on trust paths, you can go through the cyber nodes with full inspection and all that, and then you can create this multi-cloud networking that enables enterprises to build virtual cloud networking. Right? So this provides the opportunity to simplify the management of a global network that can leverage public cloud networks as well. So you will see this cyber layer is not only built over the internet, but it also leverages the public cloud infrastructure and the public cloud global backbones. We discussed how we can architect, design, and program the Cybermesh. Let's now see how it is deployed and running globally. We are re-architecting and programming the internet by creating a virtual internet or intelligent cyber layer on top of the existing internet. This programmable cyber layer consists of cyber control, cyber nodes, and zero trust paths. The question is where we are going to deploy these capabilities or building blocks of the cyber mesh. We know today a big part of the internet infrastructure is the public cloud infrastructure. Therefore, we start with deploying the cyber mesh in the public cloud infrastructure. So the three components of the cyber mesh: cyber control. We know there's no centralized control in the current public internet, and cyber control serves as the brains of the mesh. So this virtual internet that we are going to create is going to have a brain, right? So that's the cyber control. And cyber control will centralize policy orchestration and distributing policy enforcement. So cyber control is going to make the decisions and distribute policy to the cyber nodes globally. What are cyber nodes? We also learned that cyber nodes are inspection and enforcement engines. So they are, in a way, cyber security and digital experience engines with intelligence built in. So they're very different than traditional routers. They have intelligence built into that, and cyber nodes are aware of the identity of a person, thing, or an asset connecting through it. So zero trust paths, the third component, are secure virtual pathways set up using zero trust architecture. They make any communication and transaction on the cyber mesh invisible on the public internet. Again, we know if you cannot see it, you cannot attack it. Right? So if you're a user, for example, over here, and you want to connect through the cyber mesh, you are going to set up a trust path to the closest cyber node. Right? So the trust paths are between you and the cyber node. And now you are accessing some resources, maybe somewhere in the cloud over here, and that's connecting to this Cybernode. So there'll be trust path that Cybermesh has created. A mesh means each Cybernode is connecting to the other Cybernode in the mesh. So this way you can securely go from anywhere to anywhere else on the Cybermesh. And one of the reasons we are able to deploy Cybermesh on this multi-cloud public infrastructure is because the Cybermesh is built based on the modern cloud-native Kubernetes based on pods, containers, and microservices. So it's really the public, it's the underlying infrastructure agnostic. It's the public cloud infrastructure agnostic. You can deploy it on any underlying infrastructure. For example, in case of Google, the cyber nodes and cyber control are deployed on Google Kubernetes and GKE, right? In case of Azure, it is Azure Kubernetes Service, AKS. Yeah, and in case of Amazon, it is Amazon Elastic Kubernetes Service, EKS. And similarly for IBM, it is Red Hat OpenShift. As you know, IBM acquired Red Hat some time ago, and this Red Hat OpenShift is based on that platform. So Red Hat OpenShift Kubernetes platform, or ROCs, and IBM Cloud Satellite. That's the edge and on-prem strategy for IBM. And in case of Oracle, it is a container engine for Kubernetes, OKE. And now we also want to deploy Cybermesh at as many locations or POPs, points of presence, as possible, because these Cybernodes determine the user experience. Because you, as a user, connect to the closest cyber node where you have the full stack of security and networking experience, and then you are directed to the applications that are going to you're going to go to. So more infrastructure you have available to deploy Cybermesh, better the performance is. Right? So really going over public cloud infrastructure, there are two reasons. The number one is performance. You want to achieve for example, sub-millisecond latency to more than 75% of global GDP. So the cyber nodes, Cybermesh is right now deployed on 76 cyber nodes across these different public clouds. But this number continue to grow because public cloud providers continue to expand their presence. They are creating more regions, more edge locations. So that means you can continue to deploy Cybermesh on a ever expanding infrastructure. And the second benefit is the egress cost savings, like this savings, cost saving, egress cost. Because with the Cybermesh, your cyber node is in the public cloud, assuming you are a heavy user of Office 365, and we know Office 365 resides in Azure, and then you will be directed to the cyber node in Azure. That means you enter Azure and leave Azure on the cyber mesh, and then you do not need to pay the egress cost, because as you know, with the trust paths, you are invisible to anyone else. So the Azure is not going to see your traffic. The cyber mesh is going to take care of that, like, because the Azure will see that as a cyber mesh traffic. Actually, so there are cost savings by going over cyber mesh. But you also want to go beyond the public cloud infrastructure, like the colos. Equinix is one example. Like they have Equinix acquired a packet some time ago, and there's a bare metal service. How you deploy Cybernode on bare metal? Like if you have a Kubernetes solution, you can deploy it on bare metal. So for that purpose, we leverage openness. It is open network edge services software. It's also now called Intel Smart Edge open, smart edge open. So this is Kubernetes that can be deployed on any bare metal infrastructure.